series on solving Excel puzzles using SPL. Data filtering issue. Data filtering is an operation we often encounter in our daily work. For example, we often need to find out the row that meets certain criteria. For data filtering issue, Excel also provides related functions to address. For example, for very simple filtering tasks, we can directly use Excel's filtering functions. For slightly more complex filtering tasks, such as filtering by multiple conditions, we can use Excel's filter function to find the data row that meets the conditions. However, it is not always possible to write filter condition simply. For example, sometimes we may need to filter by position, such as finding out the fifth or top 5. Sometimes we may need to use adjacent rows in a filter condition, such as finding out the data row with a greater value than the previous row in a certain column. Sometimes filtering may involve category, such as finding out the row where the maximum value is located under each category. And sometimes what we want to find is not the row where the data meeting the condition is located, but the position of the data, and so on and so forth. In the face of these complex situations, it is quite difficult to solve with Excel formulas. Fortunately, it is much easier with the help of the powerful functions of SPL and its plugin XLL. Let's illustrate with examples respectively. We divide these filtering tasks into 5 categories, and each category is further divided into several situations, which basically cover most common filter issues. Filter by condition. Filtering by condition refers to finding the data that meets a single or several conditions. This kind of filtering task involves several situations, and we will explain them from simple to complex. 1. Find out the row that meets the condition. This is the simplest conditional filtering. For example, this is a statistical table for daily sales of January 2022. Now we want to find out the data with daily sales exceeding 1,000. The select function means to select data, and the E function means to read the data as a table sequence. As the expression literally means, this formula is to find out the data with sales exceeding 1,000 from the table. 2. Filter by multiple conditions. The select function also supports filtering by multiple conditions. For example, this is an employee information table. Now we want to find the employees whose gender is female and who were born before 1970 from the table. We simply need to directly write gender is equal to female and birthday is less than the 1st of January 1970 in the select expression. 3. Find out the first cell value that meets the condition. For example, the left part of the table contains the scores for different subjects. The first column is subject and columns after it are test scores arranged in order. Now we want to specify a subject and a score, and according to the specified values, find the first cell value that is equal to or greater than the score under the subject. For example, when the specified parameters are maths and 6.5, the first value that is greater than 6.5 under maths should be returned, i.e., 6.6. Write the formula in I2. Question marks 1, 2, 3 represent the 3 parameters respectively. Selected 1 function means to find out the first member that meets the condition. The first selected 1 is to find out the row whose subject name is maths. The M function is to get the score values of this row. The second selected 1 is to find out the first score that is greater than 6.5 from the scores in maths and return the result of 6.6. In the formula, tilde represents the current member, and tilde 1 represents the first child member of the current member. 4. Return part of columns in a row that meets the condition. Sometimes we may need to get part of data in the row that meets the condition. For example, the sheet 2 of this Excel file is a to-be-searched data area, where column A contains start dates and column B contains end dates, and the time periods of every row are not overlapped. Now we want to enter a date parameter, find the data row that meets the date condition from sheet 2, take the data of columns C to F in the row, and populate the taken data to C2 to C5 of sheet 1. For example, we enter the date the 18th of July 2018, and search sheet 2 for a row of data that satisfies this date condition, which will be the time period between July 17th and 21st, and then take the data of columns C to F in this row, and finally populate the taken data into sheet 1 as shown in the left figure. Write the formula in C2. First, use the select function to find the row where the date parameter such as July 18th is located, and then use the to function to take data starting from the third column in this row. The taken data will be directly populated into sheet 1 in the format shown in the left figure. Category-related filtering. Filtering by category generally refers to grouping data by a column value first, and then filtering by a certain condition. We will explain several situations of this kind of filtering task separately. 1. Search for category that meets the condition. The first column of the Excel table includes 3 categories, which are Tony, Andy, and Tim. The second column contains detailed data whose values are true or false. It is required to find the category whose detailed data does not have the true value. The expected result will be Andy and Tim. Use the groups function to group the data in column 1 by category and count the number of true values in each category. The category with a count of 0 true values is the target we want to find. In the counting results, use the select function to find out the category with a count of 0, and then take the value of its first column. The groups function is used for grouping and aggregating. ~1 represents the first child member of the current member, and #1 represents the first column of the table. 2. Filter by groups aggregation value. There is an Excel table that records the daily sales data of various products. For example, July 4, 1996 records the sales data of 5 products. It is required to find out the date with total daily sales exceeding 300,000. The total daily sales is the sum of the daily sales of all products in each day. For example, the total daily sales on July 4 is equal to the sum of daily sales of 5 products. The filter condition here is the total daily sales, which does not exist in the original data and needs to be calculated before filtering. Write the formula. Use the groups function to group and aggregate the sales by date to get the total sales of every day, and list the aggregate values in the column total sales. Then use the select function to find the data with the total sales exceeding 300,000. The groups function is a grouping and aggregating function which supports aggregation operations such as sum, count, max, max_p, and average. 3. Use groups aggregation value when filtering. There is a summary table which records the sales data of different grouped products. It is required to find out the product whose sales is greater than the average in its group. The filter condition here uses the average of products of the same group. However, unlike the previous example, here we cannot filter directly by aggregation value. Instead, we need to compare the sales data of each product with the aggregation value of its group, that is, the average value, before filtering. Therefore, aggregation cannot be performed directly after grouping, and instead, the data of each group needs to be retained for subsequent filtering operation. So here we don't use the groups function, but the group function. Group by category name, then loop through each group and calculate the average of each group and assign it to a temporary variable A, and then use product sales is greater than the average as filter condition to find data with sales greater than the average sales of its group. 4. Search for the least occurring values. For example, this Excel table has a column of month data, and each month appears in an indefinite number of times. For example, April appears 3 times and July appears 2 times. It is required to count the number of times each month appears, and then find the month or months with the smallest count value, and finally list the found month or months in column C, as shown in this figure. Write the formula in C2. The data is not standardized, and some data contains extra spaces. So we need to remove extra spaces, and then use the group function to divide values into groups, putting the same months into one group. Count the number of times each month appears and get all months having the smallest count, and then get value of the first item from each group. Mean P at A means returning all months having the smallest count. 5. Find out duplicate rows, retain the original order. The Excel table has 4 columns of data. If we regard columns 2 to 4 as a whole, there are duplicate rows. For example, the rows numbered 1 and 3 are duplicates. It is required to find out the duplicate rows while retaining the original order. Use group at U to group the rows while retaining the original order. The grouping condition is the data from the column 2 to 4, which means getting the second member to the last member of each row. This enables putting the rows with the same data in columns 2 to 4 into one group. Then use the select function to find the group whose number of members is greater than 1, which is the duplicate rows. Suffixing the group function with a "to" option means that the grouping results will no longer be sorted, that is, the original order will be retained. Find out the top n or last n, max value or mean value. Sometimes we need to focus on certain values, such as finding out the top n or last n in sales ranking, or analyzing what the maximum sales amount is and which product or order it comes from, etc. In this section, we will talk about data filtering related to sorting. 1. Search for top n or last n. This is a sales statistical table, and now we want to find out the products ranked in the top 10 by sales and their sales, and the last 10 products and their sales. First sort the data by product sales in descending order, and then use the "to" function to take values. To 10 means taking the top 10, and to -10 means taking the last 10. When the amount of data is very large, sorting the whole column will be very slow. If we only care about the top n or last n, we can also use the top function to implement. Since the top function sorts data in ascending order by default, -10 is used to take the top 10 and 10 is used to take the last 10. Pay special attention to the difference between a semicolon and a comma after parameter n. 2. Search for the max or mean value and the row where the max or mean value is located. There is a sales data table, and now we want to find out the maximum sales, and the product with the maximum sales and its sales data. To find the maximum value, we use the max function, which returns the maximum sales of 46,563.09. To find the product with the maximum sales and its sales data, we use the maxp function, which returns the data of whole row where the maximum value is located. 3. Filter by maximum or minimum value within a group, find one for each group. There is an Excel table for the daily sales of products. It is required to find out the product with the maximum daily sales and its sales. For example, the product with the maximum sales on July 4, 1996 is aniseed syrup, and its sales on that day is 96,910. Write the formula. Use the grouping and aggregating function groups to group data by order date, then calculate the row with the maximum sales within each group. The option at E means returning a table sequence consisting of the results of maxp function. The returned results are shown in the left figure, which are the product with the maximum sales of each day. Order-related search. Sometimes we need to filter data by comparing with adjacent rows or adjacent intervals, such as changes in stock price, growth in sales, etc. In this section, we will talk about order-related search and filtering. 1. Search by adjacent rows. For example, there is a statistical table for daily sales of January 2022. It is required to find out the data of date where the previous and next day's sales are both more than 500 lower than that of the date. To solve this problem, we need to determine if a date meets the condition based on the previous and next day's sales, which means we need to reference the data of adjacent rows to make the judgment. In SPL, we can reference adjacent rows using 1 or -1 in square brackets. Sales represents the sales value of the current row, sales -1 in square brackets represents the sales value of the previous row, and sales 1 in square brackets represents the sales value of the next row. After writing the filter expression as required, the result in the left figure is returned. For example, the sales on January 5, 2022 is 1,696, the sales on the previous day is 167.4, and the sales on the next day is 214.2. Both differences exceed 500, so it meets the requirement. 2. Find and filter within adjacent intervals. There is an Excel table that records daily sales data of different products. Now we want to add two columns, previous daily sales and next daily sales, to fill in the sales of the current product on the previous selling day and the next selling day respectively. For example, the sales of the product Chang on July 5 is 11,653, its sales on the previous selling day is 23,154, and its sales on the next selling day is 1,383. The direct solution idea is that as long as the order of data remains unchanged, we just need to search backward and forward to find the first row containing the same product name respectively, which are the sales data we are looking for. For example, for the product Chang on July 5, search backward and find the first row containing CHAN, which is its sales data on the previous selling day, search forward and find the first row containing CHAN, which is its sales data on the next selling day. According to this idea, let's write the formula. In the loop function, we can use a to b in square brackets to get the values within adjacent intervals. For example, -1 in square brackets represents the set of all rows from the beginning to the previous row, -1 in square brackets represents the set of all rows from the next row to the end. For each row of data, take rows from the beginning to the previous row as the search range, search this range from back to front and find the first product with the same name, which is its sales data on the previous selling day. Selected Z means searching from back to front, and @1 means returning the first member that meets the condition. Similarly, take rows from the next row to the end as the search range, search this range from front to end and find the first product with the same name, which is its sales data on the next selling day. Although the formula to this problem is a bit long, it is easy to understand once you understand the idea. 3. Take values of adjacent rows in same group. We still take the above task as an example, and now we want to solve it using a different method. As shown in the figure, the red part of the formula is to group the data by product, and then directly get the values of the previous and next rows in the group, which are the sales data we are looking for. Sales-1 in square brackets represents the value of previous row, and sales-1 in square brackets represents the value of next row. However, direct grouping will change the order of the data. For this task, it is obvious that the order of data cannot be changed. Therefore, we need to first add derived variables to the original table, which is the blue part of the formula. Then, after grouping, use the run function in the red part of formula to modify the values of original table. Finally, the green part of formula returns the values of previous daily sales and next daily sales columns. 4. Find out interval in which a certain situation occurs continuously. For example, this is a statistical table for daily sales. It is required to find out the date when the sales rises for 3 consecutive days or more. For example, from January 10th to 12th, 2022, the sales rises for 3 consecutive days. We can define a temporary variable a, which remains unchanged if the sales for the day is higher than that of yesterday, and +1 if the sales falls. Group at O means only comparing with adjacent row. If the result of the expression is the same, put it into the same group, otherwise, put it into a new group. In this way, the rows of consecutive rise are put into the same group. Finally, find out the group with 3 or more members, which is the date we are looking for. 5. Find consecutive numbers in a string of numbers and write them as intervals. A cell in an Excel table contains a string consisting of ordered integers. There are missing numbers in this string, causing it to be discontinuous. It is required to find out all sequences consisting of consecutive numbers, write them as intervals using the hyphen, and separate the intervals with comma. As shown in A2, there are intervals 1 to 2, 4, 6 to 9, etc. Split a PC means splitting the string into a sequence, during which the function automatically passes the data type. After splitting, it will return a sequence composed of numbers. Then group the numbers in the sequence. Group at I means that if the result of the parameter expression is true, the number will be put into a new group. In other words, if the current number is not equal to the previous number +1, it will be put into a new group. If the current number is equal to the previous number +1, it will be put into the same group. Similarly, we use tilde and square brackets to get adjacent value. In this way, the consecutive numbers will be put into one group. As shown in the figure, 1 and 2 are put into one group, 4 is put into one group, 6, 7, 8 and 9 are put into one group, and so on. Then, directly get the value for group with only one member, and get the first and last values for group with more than one member, and connect the two values with a hyphen to form an interval. Finally, concat at C concatenates the intervals with comma to get the result in the red box. Position-related search. Sometimes we also need to search based on the position of data, such as finding out the students in the 5th row, finding out the students with odd seat number, or finding out the students next to the student who is ranked first in the class, and so on. In this section, we will talk about position-related search. 1. Search for the nth from last. This is a sales statistical table, and now we want to find out the product ranked 10th by sales and its sales, and the product ranked 10th from last by sales and its sales. Search for the product ranked 10th, first sort the data by product sales, -1 means sorting in descending order, and then get the data of the 10th row. Search for the product ranked 10th from last, after sorting, use the M function to get the data of the 10th row from last. 2. Filter by row number. The select function can also use row number as filter condition. For example, there is a statistical table for daily sales of January 2022. It is required to find out the sales data of even-numbered days. The hash sign represents the number of the current row. Even-numbered rows are rows where the round number divided by 2 has a remainder of 0. It should be noted that the round number here refers to the round number in SPL, and the first row starts from the first data, excluding the header row. 3. Search for position of a certain value, and then take values by the position. There is a statistical table for daily sales of January 2022. Now we want to find out the day with the largest sales, and the sales of 5 days before and after the day. First use the positioning function pmax to find the position of row with the largest sales, and then take the data of 5 days before and after the day by the position. For example, the pmax function here finds that the position of the largest sales is row 12. Since the calculation of the row position here does not include the header row, but starts from the first data, 12 is returned, that is, the value of k is 12. Then use the to function to take the data from 12 minus 5th row to 12 plus 5th row, which is the data we are looking for. Note the difference between pmax used here and maxp used in the previous examples. Pmax is a positioning function that returns the position where the largest value is located, while maxp is a selection function that returns the whole row where the largest value is located. Let's look at a more complicated example. In this Excel file, there are 3 data areas highlighted by 3 different colors. Now we want to calculate a column of data corresponding to numbers 1 to 12. Calculation rule: search for numbers 1 to 12 in turn in data area 3, and then take the value at the corresponding position in data area 1 when one number is found. If the value is 0, take the value at the same position in data area 2. If the value is 1, take F plus current number under search. The expected result is shown in G and H columns in this figure. For example, the value of number 7 at the same position in data area 1 is 0. The value at the same position in data area 2 will be taken, that is, minus 10,000. The value of number 10 at the same position in data area 1 is 1. F plus current number under search will be taken, that is, F10. Loop numbers from 1 to 12. First use the pose function to find the position k of the current loop number in data area 3, that is, the sequence number. For example, the position of number 10 in data area 3 is 1, its k value will be 1. Then take the number at the same position in data area 1 according to k. If the number at position k in data area 1 is 0, take the number at position k in data area 2, otherwise take F plus current number. 4. Find out rows corresponding to the first and the last non-empty cells in each column. Similar to pmax and pose functions, pselect is also a positioning function. For example, the first column of this Excel table is the date data without empty cell, while each column from 2 to 6 has empty cells. It is required to search from bottom to top in each column from 2 to 6 to find out the first and the last non-empty cells and concatenate the cell values they correspond in column 1 using 2. For example, in column QID 3, the first non-empty cell is 5, corresponding to the date September 3, 2024, and the last non-empty cell is 3, corresponding to the date October 3, 2024. So the 2 corresponding date values will be returned. In column QID 4, the first non-empty cell is 3, corresponding to the date June 3, 2024, and the last non-empty cell is no, corresponding to the date July 3, 2024. So the date values June 3, 2024 to July 3, 2024 will be returned. In this example, we can regard each column of values as a sequence, and then find the position of the first and last non-empty values respectively, and finally take the values at the corresponding positions in column 1. Write the formula in cell I1. E at 2p means transposing the two-dimensional sequence. After transposing, D becomes a two-layer sequence, with the date value as the first subsequence, that is, D1, and each of the remaining column values becoming a subsequence. Then start searching from the second subsequence of D, and search from back to front in each subsequence to find the position of the first non-empty value, and then take the value at the same position from D1, which is the date corresponding to the first non-empty value. The function pSelect is a positioning function that returns the position of a value. By default, it returns the position of the first value that meets the condition. Adding the option at Z means searching from back to front. Similarly, use the same method to search from front to back to find the position of the first non-empty value and take the other date value. By concatenating the two date values using 2, we can get the result shown in the right figure. 5. Search for a target value and hide columns to its right. There are some numbers in this Excel table. Now we want to give a parameter, and find the parameter in each row and hide the columns to its right. If the parameter does not exist in a row, hide the whole row. For example, when the given parameter is 100, the result after hiding the column values to the right of the first 100 in each row is as shown in the figure. To accomplish this task, we can use the positioning function pSelect to find the position of 100 in each row, and then take the values from the beginning of each row to the position. For example, in row 2, the position of 100 is 2, so the first two values are taken. If there isn't 100 in a row, an empty sequence will be returned, such as row 3. Therefore, we also need to use the select function to filter out rows that are not empty. In this example, both the select and pSelect functions are used. The select function gets members meeting the specified condition, the pSelect function gets positions of the eligible members, and the to function gets the first n members. Tilde represents the current member. There are multiple tilde signs in this example. Pay attention to distinguish the values represented by tilde at different levels. The formula is applicable to scenarios where the table has unstandardized data, such as there are missing values in rows or columns and the rows or columns do not have fixed lengths. If there are more than 100 in a row, columns to the right of the first 100 will be hidden by default. Use pSelect at Z if you need to hide columns on the right of the last 100. SPL has powerful table processing capabilities and can solve more Excel puzzles. Here we list all the Excel puzzles encountered in daily work. We've compiled these puzzles into a book, and there are also free video courses available. Go to the comments to find the download address and start learning.